Alright, so this lesson is going to be on partial fractions, and we're going to kind of go over the first example we went over in class, but just so you can get a refresher of it. So our example is right here, and clearly you can't integrate it by any of our basic rules, but we do know that you can factor our denominator. So first step we're going to do is we're going to factor our denominator. And be careful when you're factoring. I know I make a bunch of stupid mistakes when factoring, so be careful and make sure that your positives in the right places, and a lot of stupid mistakes are made at this step, so be careful about that. So our denominator factors out to x plus 3 and x plus 2. So we're going to rewrite that into our equation. Next thing we're going to do is we're going to split it up. So it's 7x plus 6 equals a over our first part of our factor plus b over the next part. Next we're going to get rid of the denominator by multiplying both of these into the numerator. So when we do that, we have a x plus 3 x plus 2 over x plus 3. The two x plus 3's cancel out. And similar for b, except the x plus 2's cancel out. So if we rewrite that, we end up getting 7x plus 6 equals a x plus 2 plus b x plus 3. Next we try to figure out what both b and a are. So what we need to do is we need to find where we can make our inside of our factor 0 so that we can get rid of that factor when we solve. So our first one is x minus 3, or excuse me, x minus 2. So we plug that into our first part and plug it into the rest of our equation. We come up with negative 8 equals a times 0, which gives us 0, so we can get rid of that a, plus b times 1. So b is, when you solve for b, you get negative 8. Same thing, our other factor is x equals negative 3. We plug that into our equation. We end up with negative 15 equals a times negative 1 plus b times 0, which cancels out our b. So we can solve and get 15 for a. Then we go back and we plug what we just solved for into our equation right here. So we have the integral of 15 over x plus 3 plus negative 8 over x plus 2. When we do that, again, remember, these are just constants. So we can pull those out of our integrating and just imagine we're integrating 1 over x plus 3. When we do that, we know that we have the natural log of the absolute value of whatever the denominator was, plus whatever our numerator was outside. And we did the same thing for this part. And that gives you your final answer. Remember the plus c.
So our second example is the integral x to the fourth plus 8x squared plus 8 over x to the third minus 4x dx. And so our problem here is that the exponent on the top is bigger than the exponent on the bottom, and it doesn't work if you're doing partial fractions that way. And so before we start doing any partial fractions, we have to use long division to make the denominator have a higher exponent than the numerator, or an equal one. And so we do that by writing it out here, and I put in placeholders for the x cubed and the x because we don't have those in our original, but we need to consider them when we're doing long division. And so to do long division, you say, what can I multiply this variable by to get this? And so we see that x cubed times x will equal x to the fourth. So we put our x here, and then we multiply x to both parts of our this thing. And so we have x to the fourth, and then we have 0 for x cubed, and then we have minus x times negative 4x is negative 4x squared. So then we have to subtract just like normal long division. So I put a subtraction here with the parentheses so that you remember to factor out this negative 1. And then, so when you subtract everything, you end up with 12x squared plus 0x plus 8. And that's going to become our new numerator, so that it's a smaller degree than our denominator. And so we can rewrite this original equation to the integral x, which is what we divided out, plus 12x squared plus 8 over x cubed minus 4x dx. And so we can divide up this integral into integral of x plus the integral of our equation here. And so we're going to come back to this later when we're solving the final equation. Right now we're going to do the partial fractions for this part. And so if you factor this out, you can first factor out an x and then factor the remaining part into x plus 2 and x minus 2. And so you end up with this integral here after you factor out the denominator. And then just like the previous example, we're going to put letters over each part of each factor in the denominator. And then up here we're going to set the numerator equal to this part, but we have to get rid of our denominators. And so we do that by multiplying, and in this case we have 3 parts. So for A, you're going to have both denominators from B and C. For B, you're going to have the denominators from A and C. And for C, you're going to have the denominators from B and A. And so now we have this really long equation that we're going to work with. And so if you notice, if you were to plug in 2 for x, it would eliminate both A and B because you would get multiplied by 0. And so by plugging in 2, we can just solve for C. And when you solve for C, you get 7. And we're going to do the same thing, but for the other letters for A and B. And so -2 will eliminate A and C, and when you solve for B, you get 7. And 0 will eliminate B and C, and you can solve for A and get -2. And now we're going to solve the final equation, and so we're going to go back to this part that we were ignoring, this integral x. And if you just take the antiderivative of that, it is 1/2 x squared. And then you have plus the integral. When we plug in our letters back into this, we get -2 over x plus 7 over x plus 2 plus 7 over x minus 2 dx. And then we keep this part the same, and then this will become the constant outside of our natural log, and then it will just be the natural log of the denominator. So you have 1/2 x squared plus -2 natural log absolute value x plus 7 natural log absolute value x plus 2 plus 7 natural log absolute value x minus 2 plus c, and that's your answer.